Hello, my name is Noah Abji, and today we're going to be talking about how to simplify fractions. So let's get right into it. So if we're going to simplify fractions, the first thing that we should talk about is what simplifying fractions actually mean. So here I have a definition that I'll just read to you. Simplifying fractions is the process of reducing a fraction with a numerator and denominator with a common factor. Now, I know that definition may sound confusing, so I also have a picture diagram to show what simplifying fractions looks like, so we can come back to the definition and I can fully explain it. So here's how simplifying fractions look. In this diagram, I have two bars. Now, the bars are the exact same size, but as you can see, they're split into different sections. The bar on the left is split into 6 equal sections, and the bar on the right is split into 2 extra sections. So you could say that the bar on the left is split into sixths, and the bar on the right is split into halves. Now, with this, we can represent fractions. So let me show you two fractions on these two bars. If I started with the right bar over here, I can represent the fraction 1/2 as such. If I color only this left side in, then I'm coloring in 1/2 of this bar in total. And I know it's not a perfect coloring, but you can generally see what I mean. 1/2 of this bar is shaded and it's representing 1/2 of one whole. Now, similarly, I could represent 1/2 by coloring in 3 out of the 6 bars on this left bar, and I mean the smaller sections. So let me do that. 1, 2, 3. So if you were to look at these two bars, and I were to ask you to write a fraction with these two, you would say that this one is equal to 3 out of 6. Because out of the 6 sections we have here, only 3 of them are shaded in. On the right bar, however, you'd say it's equal to 1/2. Now, simplifying fractions actually applies to this case because I split the left bar up into 6 spaces and then shaded 3 of them in. But if we simply remove some of the lines, we can see that they're both actually equal to 1/2, which means that this fraction 3/6 is equal to this fraction 1/2. And so we took this larger fraction with bigger numbers in the numerator and denominator and brought it down or reduced it, which as you can see is in our definition here, to this smaller fraction, which is 1/2 and a lot easier to work with. And we did that with a common factor. And I'll get to that on the next slide. Okay, so going back to the example of 3/6 turning into 1/2 here, let's look at how we actually simplify this fraction. So we took the number 3/6 and turned it into 1/2. And in order to determine what we actually did to get there, we need to look at the individual parts of the fraction. What I mean is look at the top number and the bottom number, which is what we call a numerator and a denominator. So previously, our numerator was 3, and now our numerator turned into 1. On the bottom, our denominator was 6, and now it's turned into 2. So if we did the same thing to both the numerator and denominator, it looks like we divided both of them by 3. So 3 divided by 3 equals 1, and 6 divided by 3 equals 2. So we took our fraction 3/6 and divided the top and bottom number, the numerator and denominator, by the same number to get to this end fraction here of 1/2. And that's how you simplify fractions. You find, can they be divided by any of the same numbers, which is what we call a common factor. In this case, 3 and 6 can both be divided by 3 nicely to get whole numbers. And you do that to the fraction if that's possible, turning it into a more simplified fraction. So if we were to write these steps out for how to simplify fractions, here would be the 3 steps. First, check to see if the numerator and denominator have any common factors, which remember is numbers that they're both divisible by. In this case, for 3/6, it was 3, because both 3 and 6 can be divided by 3. The second step is to actually divide it by that number. Now, if they don't have any numbers in common that they can be divided by, then that's what we call the most simple fraction. And the number 1 doesn't count because any number, any whole number can simply be divided by 1. But other numbers than 1, if they don't have any of those in common, then that's what we call a simplified fraction. But if they can be divided by the same number that's not 1, then that's how you simplify it. And the third step is to repeat. And the reason that we do this is because, let's say we started with a fraction such as 9 over 81. Now, both 9 and 81 are divisible by 3. So if we were to follow our steps of simplifying, we do 9 divided by 3 and 81 divided by 3. And that would end up with 3 over 27. Now, if we only did steps 1 and 2, we would say that we're done. But we're not done because we still have a fraction that can be simplified more. We need to repeat. 3 and 27 are both also divisible by 3. So if we repeat this process, divide by 3 for both of them. So 3 divided by 3 and 27 divided by 3. We end up with 1 over 9. And now 1 and 9 don't share any factors in common. The only number that they can both be divided by is 1. And remember, we don't count 1 when simplifying fractions. So we can say that 1/9 is the most simplified form of 9 over 81, even though we had this middle step in between. So that's why it's important to repeat. All right, and finally, I have one review question that you can try if you'd like. I'll give you a few seconds to pause the video, and then I'll explain how to find the answer. All right, so the answer to this question was 3. So let's look at how we find this answer. So our first step is to take our fraction and look at our two numbers, which is 36 and 12. And it's okay that it's in this form where you have an improper fraction with a larger number on top. We can still simplify it. And see if they have any numbers in common that they can be divided by. And 1 doesn't count. So let's see, let's list out all the numbers that both 12 and 36 are divisible by. So there's the number 1, but we're not counting that. Then there's the number 2. Both 12 and 36 can be divided by 2. They can both be divided by 3. They can also both be divided by 4. Neither of them can be divided by 5, so we won't list that out. They can both be divided by 6. 7 doesn't work. 8 doesn't work. And you can do this mentally or write it on paper and actually test. 9 doesn't work. It works for 36, but not 12. 10 doesn't work. 11 doesn't work. And 12 is the last number that works. So what we want to do here is choose the biggest number that both of these are divisible by. They're both divisible by 12. So now let's actually divide it. So 36 divided by 12 is equal to 3. And 12 divided by 12, 12, is equal to 1. So we end up with the fraction 3 over 1. Now, if we were to go a different route and say we figured out that they're both divisible by 2, this is still going to work. It's just going to take a little bit longer. Let's say we used 2 and divided both the top and bottom by the number 2. Then we would get 18 over 6. Now, if you look at these numbers, 18 and 6, you can actually see that they're both divisible by the number 2 again, or both divisible by the number 3. So let's say we did one of those and divided it by 3 over 3. Then we would end up with 6 over 2. And if we look at this number again, we can see that both 6 and 2 are divisible by 2. So we have to keep going until we get to a fraction where they don't have any factors in common. So if we divide this one by 2 over 2, we get 3 over 1, because 6 divided by 2 is 3, 2 divided by 2 is 1, and we get 3 over 1 and actually end up in the same place. But it's just a little bit more efficient to just divide by 12 at the beginning. So now that we have the fraction 3 over 1, you should recognize that any fraction with a denominator of 1 is a whole number. So 3 over 1 is actually just equal to 3. If I had 1,500,000 over 1, then it would be equal to 1,500,000. And in this case, since we had 3 over 1, our answer is going to be 3. Thanks for watching.